Is it on?
It's on.
Okay. All right. From this, you looked at what you have here to identify your half reactions. When we look at this cell, this galvanic cell, you know this other side of the cell, you've got O2, you've got H2O, you've got H plus. So you look for a half reaction that has got all these things, and it was this one. It has O2, H plus, and H2O2. Then the other half cell, it has got MnO4 minus, Mn2 plus, H plus. So you must look for a reaction that has these things. This is the reaction, okay? So you know the one at the top, it's where oxidation takes place, it's the anode. The one at the bottom, it is the cathode, where reduction takes place. All right. You already know that, okay, this one is oxidized, which means our oxidizing agent will be, our reducing agent, it's gonna be here. Then the oxidizing agent, since it's reduced, it will be one of the substances here. All right, I will tell you how to identify a reducing and an oxidizing agent. Now, the first question, Lizzie suggests that, all right, we know, okay, let's first label first. So we know that this side, remember also positive here, it tells you exactly that this is a cathode. Cathode, because it's a positive electrode. That is the simplest reason. Once the electrode here is positive in a galvanic cell, that's a cathode. Clear also this side, this is a what? An anode. The reason, it's a negative electrode. They have given you here the answer. Anode, this one, because it's a what? It's a negative electrode. All right, so you know this is the anode, which means oxidation takes place this side. So even the way we have chosen our reaction, it supports this. So oxidation here is taking place. On the other side, reduction, half reaction. So you know already here it's oxidation, half reaction. On this side, it is what? Reduction, half reaction at half cell Q. Okay, then 6.1, can you read it for me, Lisa?
Okay. Can I look? Mm, so, Lizzie suggests that a manganese electrode could be used in half cell. Explain why this would not be suitable.
Okay. Before we answer, let's choose how we are going to write. So this one, we are going to write it backwards because it's oxidation. You know, reverse reactions are oxidation. Then this one, we'll write it forward because it's a reduction. All right? You know, all the forward reactions are reduction. The reverse, so that's how you will write your half reaction. So you have your half reactions. All right, Lizzie says that a manganese electrode will be used. Manganese, the symbol for manganese is Mn. It's Mn. Is there anything that has Mn here? Mn, no ions. Here on these
It's
substances, do
the
you see any Mn?
half cell Q.
That's not Mn, this. It's Mn2
Mn.
plus. Can you see that?
Oh, oh, there's
It's
nothing.
not Mn. So Mn is not part of the half cell reaction. It's not part of the half cell reaction. So we can't use it, all right? Because it's not part. That is the
Okay.
reason. Yeah. It will create, instead it will react with the substances there. So we can't use it, all right? Because it's not part of the half cell reaction. Please always be on the lookout of that, all right? Whatever we say we are going to use, is it part here? But it's not. Okay, then identify the cathode in this cell. The cathode in this cell, it's electrode B. You can say electrode B. Or the positive electrode. Have you captured that answer?
I said half cell Q.
No, don't say half cell Q. Half cell Q has got everything. You can say electrode in half cell Q.
Okay.
Yeah, when you say half cell Q has got many things. It has got electrolyte, it has got electrode, it has got PT also. It has got, yeah, you see that it has many things.
Mm-hmm.
Yes, so be specific. It's the positive electrode or electrode in half cell Q or electrode B. Write
Okay.
down the name of the oxidizing agent. Let's say also the reducing agent. You write both oxidizing and or reducing. All right, when you write the agents, you need to it must be reactants. Reactants, not products. All right, reactants. So let us look at these half reactions. Our reactant here is H2O because we are starting on this side, hydrogen peroxide. But when we come to this side, we've got this reactant, MnO4 minus and H plus. These are reactants. Remember, when you write an oxidizing agent or a reducing agent, you choose from reactants, not products. Did you get that, Liso?
No.
I say, when you write an oxidizing agent or a reducing agent, you always choose a reactant.
Mm-hmm.
Yes, for example, our first reaction, oxidation, remember it goes backwards. H2O2 is a reactant. Are you in agreement with me?
Mm-hmm.
Yes, and it will give us O2. And what else are we going to get? Plus 2H plus. Plus how many electrons? 2 electrons. That is our first half reaction with oxidation, the first one. Then the second one, it starts from the left. MnO4 minus plus 8H plus 5 electrons, and it will give us Mn2 plus. plus 4H2O. Okay. Now, if you were to write the overall net reaction, you must balance the electrons. There are 5 here, there are 2 there. So, which means we must say this times this, 2 times 5.
So you must balance
So,
the function.
we must multiply by 5 here. And here we must multiply by 2. Yes, so that you balance your reaction. So here it's gonna be 5H2O, 5O2. Here it's gonna be 10. Also here it's gonna be 10. Here it's gonna be 2. Here it's gonna be 16. Here 5 times 2, 10. 2, 8. So these electrons, they are 10, they are also 10. They will cancel each other out. Give me, what are your reactants here?
Thank you, sir, ma'am.
What are the reactants now from this reaction?
It is 5H2O plus
5H2O,
2MnO4 plus
5H2O, or 5H2O2, is it? Plus
2MnO4
2MnO4 minus, don't forget minus.
okay
Yes.
plus what 16H plus
16H plus, yes. What are we getting?
5O2
We have 5O2, yes,
plus 10H plus
plus 10, but
H plus.
H plus.
Uh,
Where is 10H plus?
Next to the 5O2.
Oh, you see that H plus appears on both sides.
Where?
Can you see that H plus appears on both sides?
Oh yes.
Plus,
In
plus what?
plus Mn 2 plus.
2Mn plus, angit.
Oh sorry. Plus 8H2O.
Let me rub to create space.
Huh?
No, I'm saying let me rub to create space. Okay. 2 Aibo. Sendrape nani ngaqondanga uyirub. Oh. Very important information. All right, plus 2Mn plus, who else is left?
Mn plus 8H2O.
8H2O. All right. So if you notice, H plus is appearing on both sides. Is it?
Yes.
So let's do maths now. There are 10 here, H's. You can see that. Here they are 16. So let's transpose this one. It's going to be 16 minus 10. So you will be left with?
So you must always take from products.
You combine. If we had more on the products, you are going to bring it. But there are more among reactants. All right? So you add them
You add
together.
something. You add them or you minus. You said we must minus 16. You said 10 minus 16.
Angithi kufana nokuthi you are adding them together, but when you transpose. Yes. Have you ever heard of addition of like terms?
Yes.
So you do addition of like terms. Since this one was 16, so you said 16, you transposed the one that was this side. So it was minus 10. You added like terms, the H pluses, all right? So you are getting it?
Yes.
Okay. So you don't leave it like that. So this is your overall reaction, okay? So your oxidizing agent, it's one of these. It's among the reactants. It cannot be any, the products can't be oxidizing agents. Uyangizwa lapho liso. Products will never be your agents. Only reactants can be agents. The substances that reacted, okay? So you choose among reactants who is the oxidizing agent, who is the reducing agent. As you know, that H2O, it's where oxidation takes place. Therefore, H2O is out. It's a reducing agent. Are you with me? I'm saying H2O2 is a reducing agent because it's where oxidation takes place. It's at the anode. Remember, you cannot oxidize yourself. Yes, so oxidation takes place on this side. So substances here cannot be oxidizing agent. They cannot oxidize themselves, all right? So on this side, reduction is taking place, which means as these ones are reducing this one, or they are oxidizing this side, they get reduced. So the oxidizing agent is found here. Remember, H plus is out because it's a spectator. Can you see that? H plus, it's a spectator. Yes. H plus appears on both sides of the reactions. So it can't, all right? Yes, it appeared both sides. It appeared. Therefore, our oxidizing agent, it's this one, MnO4 minus. But they said write down the name. What is the name of this ion?
Which ion? Minus.
MnO4 minus. What is the name? It's a permanganate. It's a permanganate ion. Permanganate. MnO4 minus. You should know it as early as grade 9. Permanganate ion. Then 6.4, write the equations For the oxidation half reaction, you already know we wrote
I
the
said, okay.
eh?
Manje, oh, of the oxidizing agent. Ungiphindele lokho, ma'am.
Which one?
When we after spectate ukuthi H plus is a spectator.
I said to H plus because it appears on both sides of the reaction. It was here and also this side. So it's a spectator. A spectator is something that appears on both sides of the reactions. It appears as a reactant, it appears as a product, which means nothing happened to it. Then we've got these other two now, which means we choose between these other two substances. Who is our reducing agent and who is our oxidizing agent? And looking at the half reactions, H2O is being oxidized, which means it's a reducing agent. Then if we look on the other side of the reaction, it's H2O2, that one. If you look on the other side of the reaction, this side, it's where reduction is taking place. On this cathode where there is MnO4 minus, which means MnO4 is reduced. Therefore, MnO4 minus is an oxidizing agent. Yes.
Okay.
But the question says it wants the name, not the symbol. You can't say MnO4. They say write down the name, not the symbol. Now, what is the name of MnO4 minus? It's a permanganate ion.
Okay.
All right, Gillis. Then, the next one, they say write down the oxidation half reaction. Already you know this is our oxidation half reaction. Remove the numbers. You don't need to balance here. Write it as is from your table of standard reduction potentials. And return the ions. We're balancing in order to write the overall net. So here is your oxidation half reaction. Did you write it correctly? It's 2 marks.
That is 4.1. No. 4.2.
You tell me.
Yeah, I got it right.
You got it right. Okay. So then we that is 6.4.1. Okay. Now 6.4.2 was asking for a reduction half reaction. Which one is the reduction? It's the one that has got MnO4. So please write that one. No need for balancing. We don't need to balance. So for 6.4.1, this is the one. We don't write these numbers. These were for writing overall. So did you get that one? Did you write it correctly? 6.4.2
plus, yes.
plus 8H plus 5 electrons.
Yes.
Okay, 2 marks. Then for the overall net, here is the reaction you were supposed to write. This one. Here. You didn't write this one?
Yes, I didn't.
Yeah, write it there as your overall net reaction. Okay?
Okay.
Yes. Then we move on to 6.5 and 6.6. 6 point, okay, let me paste also there and see. This one, it says calculate E naught cell when the switch is opened. So you know how to calculate this one. You say E naught cell. You can go to your data sheet. Your data sheet does give you. It's E naught cathode minus E naught anode, is it?
Yep.
There is a mark for writing the correct formula. Please verify on the data sheet. Is it correct, the formula? Is it E naught cathode minus E naught anode now? Have you verified?
Yep.
Is it cathode minus anode?
Yep.
Okay. You know our cathode. Ile reaction ga Mn. What is the reading there? On the table of standard reduction potentials. The value, it's 1,51.
For cathode.
So, yes, the cathode is Mn.
Okay.
1,51 minus. The anode is the other one. The one with H2O2. Ohamba no oxygen. Ithini value yakhona? U-0,68 minus 0,68. Both of them are positive. So shaya calculator. Ithini answer 1,51 minus 0,68. It's
83.
0,83 volts. So ungachecka ke wena uba
Ngithole
umise
wrong.
kanjani wena.
Mixed it.
Okay. Uyabona ukuthi kufanele ube careful leso.
Yeah.
Yes, because in physics sometimes you don't fail because you don't know. You fail because you are not careful when you do your things. Yes. Don't rush, I told you. Don't
Yeah.
rush. All right. Now we need the reasons. When switch S is closed, the reading on the voltmeter decreases. State ways in which we can minimize this decrease in the reading. There are ways. Please write them. I'm not going to write them for you. If we want at least to minimize the decrease in the voltmeter reading, there are many ways. They just want two. The first one, use a shorter salt bridge. Use a shorter salt bridge, which means quickly as electrons leave, they enter fast from the salt bridge, okay? Use a shorter salt bridge. Use a
Can I please ask, do
wider.
you have notes on electrochem?
There?
Do you have notes on electrochemistry?
Yes, I do.
Is it possible if you could send me?
All right, I will.
Thank you.
Okay. Use a shorter salt bridge. Use a wider salt bridge. Use a more conductive salt bridge. Use electrodes with a larger surface area. Okay, here they are. Copy them fast.
Yeah, more conductive.
Okay, here they are for you.
Use noted.
Okay. All right, then 6.7. We need to look at the questions. 6.7 and okay, we'll start with 6.7. Point 7. It says in a different galvanic cell, half cell Q functions as the cathode. Zach writes the cell notation for the half cell Q on the right hand side as follows. Okay. Q functions as the cathode. Okay. Standard conditions were not required. Standard conditions were not required. Identify 3 different errors that Zach made in the format of cell notation. I can identify 2 here. 1, platinum is supposed to be written at the end. You see, there. It's never written, the inert electrode is supposed to be written at the end, not at the beginning. There also, the number for balancing, 8 for balancing, is out of order. It's not supposed to be there. Even the states of the substances. Or we leave out the states, they want 3, but they were not important. Also, you see here, it's aqueous and aqueous. They were not supposed to use this vertical line. They were supposed to use a what? A comma. Can you see the reasons? Listen.
Sorry.
Listen.
Yeah. Yes, I see the reasons.
Yes. And uwabonile ama-errors awenzileyo?
Yeah.
Yeah. First one, he put PT first instead of last. And he used the what? The phase boundary instead of a comma.
Yeah.
He used the balancing number. 8, which is not supposed to be there on the cell notation. I hope you got it.
Yeah.
Yes. He used a phase boundary separator instead of a comma to separate those aqueous solutions, the AQ solutions. All right, then the last one. 6.8. What does it say? Or let me bring you a summary so that you don't make a mistake. You capture these things as I want you to capture them. Okay. For this answer, here is the solution. Please copy it fast. You can see here. Uyayibona Liso? Nathi solution ka 6.7. Nanka, all three of them. One. Yes. Seluba mufund. It's important that you capture this correctly. Okay. Then the last question is 6.8. It's 3 marks. The electrolyte solutions in both half cells. So I can wrap off now. Okay. The question says the electrolyte solutions in both half cells need to be acidified. Give a reason why H2SO4 and not HCl should be used in half cell Q. We look at half cell Q. Why H2SO4 and not why H2SO4 and not HCl should be used in half cell Q. Use the table of standard electrode potentials to assist you. Okay, let's go now to our table that has got H2SO4 and HCl. Start looking at your table, this table of standard reduction potential for these half reactions.
Yeah.
Where you will see SO4 and Cl minus. You look at those ions. I think I can only see 2. And SO4, it is a stronger what? Reducing agent. Did you pick that one up?
That I will call SO4?
Ukhona SO4. SO4 is a stronger reducing agent. Can you see that?
Yes.
Ifuna uzibhekele wena, ungabhekelwa ndim. Check out from here.
Sengitholile, if I'm not mistaken.
Suyitholile. Yes, you look at no CL. Where there is Cl minus. Remember, both of them, they've got this ion Cl minus and SO4. So this is the one, and this is another one.
Yes. Saying that's what it.
All right, tick. Then you must give me now a reason. Compare those to answer. And look also at Mn. Compare it with Mn because we'll be putting it where there is Mn. Remember, we need something that will not react with MnO4. Something that Mn will not do anything. It will neither oxidize it nor reduce it. Which one is that? Yes.
No.
There is, where is Mn?
MN
Mn was at the bottom. Eh?
MN. MN. Oh no, MN is on top.
MnO4 minus.
Is at the
The
bottom.
one who is MnO4 yes. So you compare those ones with UCl2 nobani no SO4 minus. Then you must tell me why we shouldn't use UCl. HCl if we want to acidify. The reason is clear when Aliso, okay? It's simple. It's because Cl minus will be oxidized by MnO4 minus to form Cl2, while SO4 2 minus will not. You must know that.
And how did we discover that? I'm confused.
You are confused.
Yeah.
Okay. Look at your strength of oxidizing ability. All right. Now here is your R. You see, look at that table. That MnO4
Minus.
is a stronger oxidizing agent.
Yes.
Yes, it's a stronger oxidizing agent. All right.
Then Cl.
Yes, than UCl UCl minus. Remember, we've got OCl minus here. All right. Yes, therefore, it is going to oxidize ubani? UCl minus. Yes, UCl minus.
Because it's a
Not
stronger
UCl2.
oxidizing agent.
Yes. Also look at something here. A reason
And then
why it's not SO4. Okay, there's something you need to check out. Check SO4 2 minus in your table. Can you see that it's written as a reactant? It is on the same side as MnO4.
Mm-hmm.
Can you see that?
Yes, I can.
That SO4 minus is on the same side as MnO4, but Cl is on the other side.
Mm-hmm.
So MnO4 definitely cannot oxidize SO4 minus to SO2. They appear on the same side. I hope you can see what I'm talking about. Okay, let me try to copy and bring this to you. All of it, so that you are going to look at it holistically. Let me wrap this one, which is not showing the other reaction. Okay. So if you look here, here is this. Look at SO4. You can see SO4 2 minus, Cl minus,
Mm-hmm.
MnO4 minus.
Mm-hmm.
So when we put in here SO4 2 minus ions, because it's SO4 2 minus ions that we are adding here, or Cl minus ions. Okay? So
Mm-hmm.
who will be oxidized between between this ion and this one? Both these are on the same side. Can you see that?
Yes, I can see.
So MnO4 definitely, because it will undergo a reduction, it goes this way. So this one has to go backwards. There is no SO4 this side. You can see that there is no SO4.
Mm-hmm.
So it cannot oxidize SO4 minus ions. But it can oxidize the Cl minus ions. Remember, this reaction is going this way, is it?
Yes.
Yes, so Cl minus ions will definitely be oxidized to who? To Cl2. Now, do you understand the explanation?
Yes, I can.
Yes, because actually this one is a stronger oxidizing agent
Uh,
than this one.
agent. Yes.
Yes, both these
Pencil.
ones and these ones, they are weaker. They are weaker because they are at the top. This
Mm-hmm.
one is the weakest because it's far. But the problem is SO4 minus is a product, not a reactant. Can you see on this reaction?
Yes.
It's not on this side. Otherwise, if it was on this side, it was going to be oxidized. All right?
Yes.
Yes, but now you can see how do you oxidize it. They appear on the same side of the reaction with MnO4 minus. So it can't. All right?
Yeah.
But Cl minus can be oxidized to Cl2. I hope you got the reasoning.
Yes.
Okay. So when you write down again, that's how you write it. You will say like this. Cl minus can be oxidized by MnO4 minus to form Cl2. But SO4 2 minus cannot be oxidized.
Yeah.
Oh, I must give you a summarized version. There is a summarized version. Okay.
Mm-hmm.
Okay. Are you good now?
Yeah, bon.
Okay. Then the other question. It was a 30 marks question. These questions, they carry a lot of marks. Okay, let's now look on this one. This one is an easy one. I hope they will give you a cell as easy as this one. Was it not easy when you were answering it?
It was okay.
It's very easy, this one. Both of them are metals. You see, there isn't much information. All right, let's look at this one. In the standard cell shown in the diagram below, a copper electrode is placed into a solution of blue copper sulfate and a chromium electrode is placed into a green chromium sulfate solution. The voltmeter registers a reading. They can also ask you why chromium is placed in a chromium sulfate solution so that it does not react with the electrolyte. All right. Remember, chromium cannot react with chromium. Are we clear there?
Yes.
So, is this a galvanic or an electrolyte? Electrolytic.
Galvanic.
Galvanic, good. Write down the formula for chromium trisulfate. Go to a crisscross. Symbol for chromium is Cr3. SO4 for sulfate. These are the things they were supposed to memorize in your grade 9. 2 here.
Oh, yes.
Cross multiply. Cr times 2, Cr2. SO4 times 3, bracket, SO4, bracket 3. That is the formula for chromium trisulfate. Everyone?
Yes.
Yes. Then define the term reduction. What is reduction?
The electrode where oxidation takes place.
Oh, I didn't say what is a cathode.
Oh, the gain of electrons. Sorry, I'm looking at 6.2.
Yes, gain of electrons. Oh, you are defining an anode when. Good. All right. Okay, now they want, okay, it's important. Let's identify our half reactions here. Let us look at, we need copper 2. It's copper 2 and chromium. Okay, we are going to look for these electrodes. I want to bring in the table to that side. Where is yours? It's CR3. It's CR and who? It's copper. Eh?
Pardon?
Is it it's CR and which one and which electrode?
And copper.
It's CR and copper 2, ne? CU.
Yes.
Okay. Where is copper now? Assist, where is copper? I can't find CU on this table.
CU, if I'm not mistaken, was on the top.
Oh, at the
Oh,
bottom.
it's at the bottom.
Yes. So, and it's CU2. Okay. I found it. I thought it was gonna be at the top. All right. So there we are. There we are. Okay. Now we need to identify the anode. Already we can see this one is the anode. It's where oxidation takes place. It's at the top there. We can see that this one is the what? It is the cathode. It's where reduction will take place. All right. Which means this one is going backward. You will write that reaction. That is your oxidation half reaction. This one will go this way. It is your reduction half reaction. All right.
Okay.
Yes. So you know both your reactions. If we say you write your reduction half reaction already, you know it. This is the one. It is Cu2 plus. Did you write it like that?
Yeah, well.
Plus 2 electrons. And what do you get?
See you.
Cu. Give yourself 2 marks if you wrote it like that. Define an anode.
The electrode where oxidation takes place.
Identify your anode. Your anode is Cr. There
Yes.
it is. Did you write like that?
Yeah, well.
Yes, your anode is Cr. 6.3.5. Describe 2 observations that can be made in the chromium half cell. After the cell has delivered current for a significant amount of time. In which direction our electrons are moving? They are moving from Cr to Cu.
See you.
Is it?
Yeah, well.
Isebenza kanjalo. All right. After some time, you need to tell me what do you think is going to be observed?
Can you please repeat the question?
Yona le question, the one that is there.
Oh.
That
Describe
says
2
after some
observations.
time.
Mm-hmm.
Yes, after some time. What will be observed in the chromium half cell? What is going to be observed on the chromium side? Remember, it is the electrons are moving. What will happen?
The electrons are moving from Cr to Cu.
Yes. Could we describe 2 observations?
Observations.
Yes. What is going to happen?
Where the cell has delivered currents from a significant amount of time.
Yeah, electrons are moving this way.
And are going to Cu.
Mm-hmm.
So azowehla.
Yes, imass yakho uzozaca because it's losing loss of electrons. All right.
And then Cu uzonyuka because it's gain of electrons.
Cu, yes, it will gain, but we are kuthiwena must be specific what will happen on the chromium side.
Oh,
So the
chromium.
chromium anode will what? It will lose mass. It will become smaller or it will decrease, all right, in mass. However, you are going to write it. What do you think is going to happen to they showed you colors for a reason. The color here and here, they even talked about it. The green chromium sulfate.
Oh,
When,
it'll lose color.
what will happen?
It'll not lose color.
No, it will become darker. All right?
Oh, okay.
Yes. So yenye into ke ukuthi the color will darken. Okay?
Okay.
Yes. Those are the two observations that can be made. I hope you captured them.
Captured what, ma'am?
The explanations I've given you.
Yes.
Can you read them for me? How did you write them?
I said OCR is gonna decrease in mass and will gain
Yes.
more color, creating
And what is the green color will what?
resulting in the green color going darker.
Okay. Yeah. Ungathi also the most appropriate ubhale separately because it's two reasons. Okay.
Okay.
Sithe CR will decrease in what? In mass. The other one, the green color of the electrolyte will darken. Okay.
Mm-hmm.
Yes. Or the green color of the solution will darken. Okay. I hope uyabona ukuthi ama-observations enziwe kanjani. Angithi uyawabona?
Yeah.
Ama-marks la alahlile that you cannot miss. Okay, now let's move on to other questions. I will remove these questions which we have already answered and put in the new ones. Let's look at these ones now. Write down the chemical equation for the net cell reaction that occurs in this cell. 3 marks. This one is a bonus. You need to balance electrons. There are 3 there, there are 2 here. So quickly remember it was Cr reacts to form Cr. You do this on your rough work where you add them. We want a combined thing here. All right?
Mm-hmm.
Yes, we are not interested on how you got it. So please balance this. You do it roughly, separately. We don't want to see you writing these two reactions.
Okay.
Yes. Balance the electrons. How am I going to balance them? Tell me.
We are gonna make our electrons
Multiply these 3
yes
and
to
2.
each other.
Okay.
Yes.
So
So
here we'll say times 2.
2
Here we'll say
and
times
3.
3. All right, then let us write them. It's gonna be 2 here, 2 here. It's gonna be 6, 6, 3, 3. This will cancel this. You know how to write it again now. Write it yourself. Did you write it and you got it correctly?
No, because I was doing it the wrong way. But since we did the first question and I saw how you do it now, I have knowledge. Think I understand. What
Oh,
is
okay.
required of me.
All right.
Yes.
Then also this one, it's easy peasy. You calculate the initial voltmeter reading. You know the formula we use? Cathode minus anode. So it's gonna be 0.34 minus 0.74. Did you get it?
Mina ngazi kanjani, but I keep mixing my for my I keep mixing my anode and my cathode.
Uyazibona i-cathode ile ngezantsi. All right? You start with A. Think of your letters. When you write them, you start with A, B, C. Angithi?
Yeah.
So A at the top, C at the bottom. Anode is the
Okay.
one at the top. All right?
Yeah.
Yes, the one that is more negative. Okay, so you see where you made a mistake. Correct it, ke uzoyilungisela wena. All right?
Yeah. Yeah.
Yes, yes. Fix it. Don't forget to write the minus that comes with the equation because it's going to be 0, comma. Remember ke when uyibhala i-equation ubuzolithola ima kule equation ubothola u-1 nje kuphela out of 3. 0,34 minus of
Yeah.
minus
7 4.
0,74. Ube careful. There is a minus that comes with the equation. Ungawukhohlwa lo minus.
Okay.
Yes, so that will be your E naught for this cell. Ithini answer?
Mm. I'll tell you just now. 0,334 minus -0, I'm
Izofana
getting
nale yakho 1,08.
118. Yeah.
It's just that eyakho
In
i-negative.
a negative,
Yes, bidansile.
but
Yeah. All right. Now 6.5.2. If the initial concentration of copper sulfate used was greater than 1 mole per dm cube. Okay, we've got now a higher concentration of what? Of copper sulfate. Fully explain the effect this will have on the voltmeter reading. All right, you must check first, is Cu2 plus a reactant or a product? It's a reactant. Can you see that the copper sulfate ions it's a reactant? Please, uyayibona?
ungasamani bangisayenze notes. Or okay, your question, ma'am, is
Githi, if you look on those half the reaction your
the half
balanced equation ubusuyibhalile the net overall qala ufuna ukucheck.
i-voltage yam.
I-net overall reaction
Oh,
ubusuyibhalile na?
bengingakayibhali.
Bente ibhala ngithi ngoba ndifuna undi-identifyele something uze sikwazi uexplaina le nto ebendifuna ukuchazela yona.
Okay. 3 plus 6. Don't give me 3. Cu 2 plus 3. Okay, sengiqedile.
Okay. Now, if you look on your reaction, you've got two reactants, Cr and who?
Cu.
And Cu, which means these are your agents. If the question could have asked you, what is a reducing what is an oxidizing agent. Fanele ukwazi uzi-identifya by yourself. Who is an oxidizing, who is a reducing agent. Between these two only, remember that. I told you your agents, they are always among the reactants. All right, now this question is saying, initial concentration of copper sulfate used was greater than 1 mole. If it was greater than 1 mole, now the concentration is increased here. Remember, Cu2 plus is coming from, it's coming from this one, Cu2 plus ions. They are here, Cu2 plus. And this Cu2 plus, it's an aqueous solution, it's a solution. If now the concentration is increased, it's a reactant. You need to look what the question says, fully explain the effect that it will have on the voltmeter reading here. You know, if the concentration of the reactant is increased, the forward reaction will be favored. All right?
Increasing
Yes.
concentration will also increase the products.
Yes. If the concentration of the reactant is increased, forward reaction will what? Will be favored. If forward reaction is favored, it means the voltmeter reading will also increase. Yes. Iyona nto ebendifuna uyibambe leyo. But if the concentration of the product was increased, remember, reverse reaction was going to be favored. Then if reverse reaction is favored, it means the voltmeter reading will what? Will decrease. Yes. Now, I want you to write it in the manner your exam will expect you to write it so that you don't miss any marks.
Okay.
Yeah, I will always refer you to how your exams will expect you. Me, I just summarize for you so that you see what will happen, all right? Now, this is the language they want from your papers. Please write it like this.
Okay.
You done?
Yes, almost.
Okay.
I'm done.
Okay. But I think at least now you understand it.
Yeah.
Yes. because I already told you, you check which reaction is going to be favored, who is increased or who is decreased. Then you go to your balanced overall net reaction to identify the substance increased or decreased, whether it's a product or reactant.
Reactant.
Then from there you will explain. Use ke li-chart Elias principle bayawufuna ke but kwa-DBE uyabona ubuzowathola ama-marks akho, uyabona with the explanation that I gave you, it's more than enough. Ndibuye ndize lana, write down the chemical formula of a suitable reagent that can be used in the salt bridge. You can use KNO3. It's a salt. All right. Your salt cannot contain a sulfate. That's one thing you need to bear in mind. All right. Can use KNO3. It's a famous one. It's the one that is loved, this salt. Most salt bridges, they prefer this one. Okay. Okay, NO3, it's the most suitable most of these galvanic cells. Then explain how the salt bridge maintains electrical neutrality in the chromium half cell. The question is specific. In the chromium half cell, refer to changing ionic conditions as well as movement of ions. Alright, asike siqale ngo-6.7 sizobuyela kula 3 marks. Ake sizoqala la ngo-6 marks ulahlile lana. Ise-notation yalana sithe omphu anode angithi ulona. So uzothi CR solid because it will show the phases and conditions. Bese uthi slash CR 3 plus. It's an aqueous solution. Angithi aqueous. You write the concentration. 1 mole. They said you must show it per dm cube. Kunini ndirhalela lo 6 marks nje. Bhansela. Then close bracket. You've got a salt bridge. Then we've got who? Cu. Which is also a what? A solid. Slash Cu 2 plus. It's an aqueous solution. You need to write the concentration. What is the concentration?
Concentration
Is 1 mole per dm cube.
Yeah, 1 mole per
Yes.
decimeter cube.
Yes, immediately after writing them. Don't forget to write the way the wrong. It's not showing reduction, it's showing oxidation. We are supposed to start with the We're supposed to start with Cu2 plus, ne? Lisokuthenwa
Mina
nikorekishi.
ingoba ngenza into wrong.
It must show reduction, okay? As I write it, because I said it's a cathode, it must show reduction. So, comma, 1 mole per dm cube. Cube, vali bracket. All right. Then ube suthi slash Cu, 1 mole loyana. Cu, which is a solid, and you write at 25 degrees Celsius. I hope you captured this side correctly. Ulibhale kahle namdeni side. Yes, when uzobhala kahle Cu2 plus, uvula ama-brackets laphayana ezansi. Aqueous solution, comma, 1 mole per dm cube, you close bracket. We say slash Cu bracket solid at 25 degrees Celsius, 6 marks. Ma-marks amangaka, into elula kangaka. Wena kubuzothola how many marks ke liso?
Bengithole imakhi ye-Salt Bridge, ngithole imakhi yase-R. And then okay, CR3 no. Okay, bengayithola
Wena
na.
ubhale
Oh, I didn't. I
u-SO4.
used commas actually.
Wabhala usolid nakwi-aqueous solution, uyazibona?
Boo.
We.
But like, how do I know when something is aqueous or
Once
solid?
it has a plus or minus, means if it's an ion, ions are found in solutions.
Oh, it's automatically okay.
Yes. Once
Sushiye
they have
indaba.
ion, it's an aqueous solution layer. If it's not an aqueous, it's a solid or a gas.
Okay. Nakhona ama-gas siyabona. Okay.
Ndifuna ucheck uba iteyibuli lenu alinitsheli yini na. Kho bheke kulona. Alikunika ii-tips. Strict.
Periodic table.
Hayi eli table ama-standard reduction potentials ebesilisebenzisa. Check it out. Lithini lona? Alisho lutho about hayi liyakubhalela.
Isibhalela.
Ama-phases. Kodwa hayi aluwabhali wonke. Sengiyabona
Yeah.
libhala only if it's a
Ugas.
gas. Lokhu ama-aqueous solutions hayi.
Ayingeni.
Alisho kwasani. It shows you gases only. O-aqueous solution alibabhalile. Kodwa usubabambile o-aqueous manje. Onke
Yes.
laba abano-plus no-minus. O-aqueous lapho. All right. Then u-6 marks ke loyo. Masise 6.6 point bekuthiwa explain why how is going the salt bridge to maintain in the chromium half cell. Remember, in your answer, refer to changing ionic conditions as well as the movement of ions. All right, it's clear here. We already said from chromium, what happens? The electrons are flowing into the copper one, which means it's an anode, this one. So the movement of electrons, which means the solution here, the negatives are leaving. Then what will happen? The salt bridge will bring in the what? These negatives that are leaving, the N ions. Remember the Cr, you explain only by referring to who? To Cr. Only. You don't bring in another substance. So what's going to happen there? Listen, I'm listening.
My answer was I gave it before you gave me the exercise. We talked about ions and cations. So I said for 6.6.2, ions from the salt bridge migrate to the anode and the cathode. The cations migrate to the cathode to maintain electrical neutrality of the solution.
Okay. Let's read the question. It's interested only in who? The question.
Cr.
Cr. Okay. You were not going to get something from how you explained. All right. So refer to changing ionic conditions as well as movement of ions. All right. Okay. So here, since the negative ions are leaving, you see, and the negative ions, which your SO4 2 minus, are leaving. Therefore, there is an increase now in concentration of Cr3 plus ions. Please write that one. That is the first one. Increase in concentration of what? Of Cr3 plus minus ions. Not gonna write it, all right? Increase in concentration. Please write that one, all right?
Okay.
Then, what happens when the concentration here of Cr3 plus ions increases? Now, N ions from the salt bridge will migrate into the solution. Please write that one. N ions.
Migrate into the solution.
Yes, from the salt bridge will migrate to the what? To the solution or to the electrolyte. Sunamabullet awu-2, suthola 2 marks. anions will migrate to the solution or to the cathode because it's a diamond to the anode, dang it. Have you captured this statement?
I'm capturing the third one now.
Okay. So now anions will migrate from the salt bridge into the solution. Then the last one. These Cr plus ions, because there is more of them. These cations, remember they are positive. They will in turn migrate into the salt bridge. You see that there is an exchange.
Because they are positive.
Even i-salt bridge angithi as iqhubekeka inikeza, it's inert, you see.
Angikuzwa.
It's inert, but awuzubhala loo nto. You give me, I give you. So the salt bridge, remember, it releases anions to the electrolyte solution. Then in turn, the electrolyte solution, because it has got many of these Cr plus ions, these Cr plus ions will also migrate, the cation ions will migrate into the salt bridge. All right?
Okay.
Yes. Cr plus ions, or you can say cation ions, will migrate in turn to the what? Into the salt bridge. Thus maintaining the electrical neutrality in the what? In the in the what? In which, in the question was saying? In the chromium half cell. Hope we are good now.
Yebo.
Yes. Uze wabuya ugesi.
Like yebo, ubuye the day after too. So hamba 2 days.
Okay. All right. Hayi-ke, that is it for today. Sobonana kusasa-ke.
Okay, ma'am.
Good night.
Ngizoqhubeka nama-question. Good night.
Uqhubeka. Kanti unawo ama-past papers?
Yebo, nginawo.
Okay-ke. Good night.
Good night.
Night.